Explain how a physical property which varies with thermometer may be used for the measurement of temperature and state examples of such properties. Explain the need for fixed points and state what is meant by the ice point and steam point. Discuss sensitivity, range, and linearity of thermometers. Discuss the structure and reaction of liquid in glass thermometer, including clinical and a thermocouple thermometer, showing an appreciation of its use for measuring high temperature and those which vary rapidly. Describe and explain how the structure of a liquid in gas thermometer affects the sensitivity, range, and linearity.
So, which unit from your book I told you to read?
Unit 8.
Can you open that unit?
Yes, sir.
Okay, so did you get the learning outcomes A anywhere on the topic? They are saying physical properties, right?
Yes, yes. The first page.
Yes, that is page number 115.
Yes.
There is a table, right?
Hmm.
Yeah, you write this table on your copy. You write this table. Please do it, huh? Here we have four, right? Four physical properties.
Yes, sir. Done.
So the third one, you are getting resistance of a piece of metal, and there is written resistance thermometer. Beside that, you write thermistor thermometer. You give hyphen, then write thermistor thermometer, and also beside that you write digital thermometer. Okay. Sometimes we are using digital thermometer, right?
Yes.
Uh, that one is actually this one, resistance thermometer. So here we are using the property of solid, liquid, gas, right?
Yes.
Look here, the first one we are having the liquid expansion. Liquid expansion due to temperature raise, and this volume expansion of liquid is linear. It means the way the temperature is increasing, the volume of the liquid also increases same way, right? There is directly proportional. So using this idea, we can make the thermometer, right?
Yes.
You know, the mercury in glass thermometer or alcohol thermometer we are using in lab. Mercury thermometer we are using for clinical purposes. Those are using this idea, right? or this property. And another one is thermocouple thermometer. That one is actually related to temperature change. I show you this one now because already you have some idea about electromotive force, how it is created. Look, I'm drawing the diagram, or you can have the diagram. Can you write a heading thermocouple thermometer?
Yes.
Can you please write a heading thermocouple thermometer? Yeah. Then go to page number 124.
Yes, sir.
Okay, look, there is one diagram, right?
Yes.
So can you please draw this diagram? Figure,
Figure 8.13.
yeah, 8.13. That diagram you draw, and write this equation.
Yes, sir.
After drawing this diagram is done, you there is an equation. You see, E is directly proportional to del theta.
Yes.
Where E equals EMF for voltage produced, then del theta is temperature difference between two junctions. Yeah.
Yes, sir.
Okay, then you write next page. You see, we have advantages, right? Advantages of thermocouple thermometer. You write also that one. Only one and three you write. Okay. Uh, all the advantages you do not need to write. Only one and three. These two you write.
Yes, sir. Done.
Okay, very good. Look, we are done with A and D, right?
Yes, sir.
Huh? Can you see? We are done with A and D, right?
Yes.
D for the thermocouple one you wrote, and the liquid in glass thermometer we discussed, right?
Yes.
Okay, so it's clear to you, right?
Yes.
Then liquid in glass thermometer, do you need to write or you can remember that one, what I discussed?
I think I can.
You can remember. Okay, now we are starting with two fixed points. Huh?
Hmm.
You see, learning outcome B. Okay, learning outcome B. Explain the need for fixed points. So you write the heading two fixed points. Two fixed points. You wrote the heading, then after
Yes.
that you write first one, that is ice point. Ice point, you give hyphen, then you write ice point, you give hyphen, then you write the temperature of melting ice. The temperature of melting ice is 0 degrees Celsius. Which one is called lower fixed point? Which one is called lower fixed point to calibrate a thermometer?
Yes, sir.
Which one is called lower fixed point to calibrate a thermometer? Then you write another one, steam point. Steam point, huh?
Yes.
So you give hyphen, then you write it is the temperature of boiling water. It is the temperature of
Boiling water.
it is the temperature of
Boiling water.
boiling water. Uh, what is 100 degrees Celsius? It is the temperature of boiling water. What is 100 degrees Celsius? And it is used to calibrate the upper fixed point. Upper fixed point of a thermometer.
Yes, sir.
Okay, very good. Now I am showing you what is the need for these two fixed points. Okay, I am you write the heading need for fixed points. Write a heading need for fixed points, and after writing this, you draw a thermometer the way I'm drawing. Mm. And here you give a caption, figure caption, uncalibrated thermometer. Uncalibrated means unmarked. Unmarked, or you can say unlabeled, or unscaled. Unscaled thermometer, right?
Yes.
So is this thermometer is ready to get any temperature or to measure any temperature?
No, sir.
So what we have to do, we have to make it calibrated.
Yes.
And after calibration, you can measure the temperature. Okay, and for this calibration, we need two fixed points, right?
Hmm.
So you write here, after drawing this, for calibrating the thermometer. Calibrating means what?
Marking.
Yes, mashallah. For calibrating or marking the thermometer, calibrating or marking the thermometer, we need two fixed points, right?
Yes.
Can I receive a call
Yes,
for
sir.
a
Sure.
while? Yeah, please give me a minute, huh? Okay, sir. Clear? So before today's class, did you had this idea about calibration of thermometer?
Yes.
So the way I discussed, you had this idea like this, or you had little bit idea?
Yes, I had a little bit like this.
Okay, now what we have to do for calibration? We will do two things. Okay, only we will do two things for calibration. You next. I am. Can I clear all these drawings?
Yes.
Okay, now clear all these drawings. Then you write. Uh, or you can draw here only, that is all enough. You can draw uh, this way. You draw the thermometer, uh, then here you write the first step beside the thermometer. First step, step one. uh, Step one is we will fix the valve of thermometer. We will fix the bulb of thermometer in melting ice. Okay, why will fix the bulb of the melting ice? Bulb of the thermometer in melting ice to get lower fixed point. To get lower fixed point and then mark it with permanent marker. Okay,
Yes.
permanent marker. Is it clear?
Yes, sir.
So for example, our thermometer which you drew just now, we we have a mark here. You would give a mark here. This one, huh? This one is our ice point. Okay,
Yes.
ice point, and ice point means 0 degree, right?
Yes.
So you mark it at this point here. You write 0 degree, huh? Zero. Okay,
Yes.
and the whole one is marked in degree Celsius. Okay. Now fixed point ice point you write, and then you write here 0 degree Celsius. Eh? Ice point. Eh? Ice point. Eh? Done.
Yes, sir.
And second step we will do. What we'll do? Step two.
We will mark the boiling point.
We will fix the bulb. We will fix the bulb of thermometer in boiling water to get upper fixed point, right?
Yes.
And mark it. Huh? Is it clear?
Yes, sir.
So, for example, you are getting here upper fixed point at the top, right?
Yes.
Here it is
100 degrees Celsius.
100. Now, third step, I'm writing here. For example, 0 to 100 is 10 centimeter, right? 0 to 100 degrees Celsius is 10 centimeter, okay, in your ruler.
Yes.
Then 1 centimeter is 1 centimeter is 10 degrees
10.
Celsius, right?
Yes.
Then mark it, eh?
Hmm.
Mark it. Okay. In between
Yes, sir.
0 to 100, you will divide into 10 equal parts, right? Mark it. Then each of the part is giving you how much? 10 degrees Celsius, isn't it?
10 degrees Celsius. Yes.
And again, Again, 0.1 centimeter is 1 degree Celsius, right?
Yes.
That means 1 centimeter you can divide into 10 equal parts, right?
Yes.
Then each of the part is giving you 1 degree Celsius.
1 degree Celsius.
So this way, this is the way of calibration, right? This is the way of calibration. Are you clear about this?
Yes, sir.
So we are done with B, right? Learning outcome B.
Yes.
We are done with learning outcome D. Okay. And now we will do part C. Will you offer your prayers?
Yes.
So I am giving you break. Again, we will start at around 6:35. Okay. And by next 6:35 to 6:55 we will finish our last part. Okay,
Yes,
is
sir.
it okay?
Yes.
Because your next class is 7 o'clock. Okay, Allah Hafiz, eh?
Allah Hafiz.